Hey folks, I'm Dave.
And I'm Ben.
And here we are again. No need for introductions. This is part 2 of our structures video. We've separated this into 2 parts because, well, to be honest, I didn't want to really rush it, and I didn't want to end up with a video that's like 45 minutes long. Also, we covered some really important information in that first video, which goes over all the basics of what a structure is and how to set it up, and it will make sense of this program behind. So if you haven't already seen that, please go and watch it first, otherwise this really will not make much sense. Or, if you are very, very comfortable with structures and this makes immediate sense to you, then please feel free to carry on. You might not need to go back. But yeah, even more structures, you'll notice, is the different name of our program this time. So there's a few things that we need to go over here, and we'll just jump straight back into what we were doing. So we have here an array of structures, an array of 3 structures. The array is called shape. It has 3 elements. Each one is a structure of 6 properties. But it's quite a lengthy way of setting it up. You know, you really might not want to write out a whole load of lines, especially if you don't need these properties to all be different. So for example, if it's something like an array for your enemies in a game, where they're not going to all be on screen at once straight away, you might be generating them as you go, in which case it doesn't really matter what the properties are to begin with, because when you make one, you then set the properties. And typically you would do this in some sort of little function, like a for loop that does this. This is what happens in all the FUZE demo programs, and we'll show you an example of that at the end of this video. So let's first of all, sorry man, I'm going to reach over there. Let's first of all just get rid of, not all of it, just this, and we'll make it go back to normal. So this is how we started with our first basic structure. A simple structure with only these properties. It's no longer an array, so I can't access this with shape open brackets. Sorry, yeah, if you do that for me then, shape open square brackets 0. This no longer is valid. I have to do shape dot something. And in the one that we just deleted, now that will not work because we don't have a property called something, with the exception of sprites, which we'll get into actually in a few different videos. Anyway, I'm rambling now. When we want to define an array of structures, for example, if we wanted 120 enemies, and they're not all existing at first, we're going to generate them, but our array needs to be 120 elements, and each of those elements needs to have position, status, colour, whether or not it's been hit, or I guess that's status, all these different things, size, velocity. You will not want to do 120 separate elements to an array. You'll be here all week doing that. So instead, you should do something like this. First of all, let's, for an example, let's just move this down a second and make a new structure up here. The weird part is, and this took me a little while to get my head around, until Luke, our programmer, just kept saying, "You're doing it wrong, you're doing it wrong." I eventually got there. You have to declare this as an array. Array. As a Harry. So you say array. This is an array. And then you have to name the array. So if we call it enemies for now then. Right. Now because we're declaring an array, we need to declare how many elements are in the array. So we said 120. Let's just go with 120. Right. 121. I should know better. I should have said 121. That's how I get what I need. Oh, yeah. Okay, fair enough. I stand corrected. I've lost my train of thought. There we go. Back to 121. Things are where I understand now. So we're declaring an array called enemies, 121 elements, and we want each of those elements to be a structure. So if we do an equals, and just like before with our shape structure, we do an open square bracket, go down a few lines, do a closing square bracket, and now we've given the properties. So let's do a dot pos or xpos like we did before. And let's just do, actually there's sort of a convention here that I will mention. If you're declaring something like this, and you will see this in the FUZE demo programs, if you're not going to be using them until you generate something, put a -1. This really helps me just remember, oh yeah, that's not being used. It's not valid. So xpos is -1, ypos might be -1 as well. Don't forget the commas in between all the different properties. And you get the picture. If we do this, yeah, we'll do dot state equals -1. One more, let's say. What could we have?
Size.
Yeah. 0 or -1 again. So these are all unused properties for a structure, an array of structures, which we're going to use in a program, or we might use in a program. Ben, could you just do a print statement and access the Y position of the 120th enemy? Let's just move this up like this, make it bigger for people to see. I'm liking this 2-player coding that we've got on right now. We're doing quite well. So enemies. The 120th.
120th.
Yeah, mate. There's your test.
Y position?
The Y position, yeah. Perfect. Perfect. And let's see if it works. Wow. Would you look at that? We get our -1.
Trying to catch me out.
Hey, it's too good for me. It's that brain that's been through the A-levels, practiced, you know. I couldn't do that anymore. Too slow. So this is how this looks. And you know, it's exactly as we were using in the previous video with shape, open bracket 0.xpos. You know, we just have our array, the name of our array, the element that we want, and the property of the structure contained in that element. Hopefully, seeing this will help you to read all of the FUZE demo programs. In fact, let's just go into one of the FUZE demo programs and have a look now. Let's, I think we'll go with 3D Crazy Shooter, because I know that we do that all over the place there. Let's get rid of the print here. And there's my name. Love seeing that, obviously. Total narcissist. You've also, I mean, here's a great example too. Straight away, we've got an array of structures. The enemy models in FUZE, in 3D Crazy Shooter, sorry, in the FUZE demo programs, each of these models needs 3 properties, which is the object that contains the model, which it is, so for the T-Rex, there it is, I'm loading that model. It's a scale as well, which is actually a multiplier that I multiply the scale by. So this T-Rex is huge, so it only needs a scale multiplier of 1, although I did a workshop recently, and I showed the kids this, and I made it always spawn T-Rexes, and then they were asking me to do a scale of 100. And I might show you what that looks like at the end, it's quite funny actually. And then the score multiplier for the last property of that structure. And notice that all of these are in our square brackets. Now the reason that these are laid out horizontally is because 3 properties, and there's a lot of them. If I did this as 3 separate lines, well, yeah, 4 including the square bracket and and the closing square bracket, you're talking about 4 lines for each of these. It just looks too much. It's actually more confusing to the eyes. So I opted to do it this way.
And also, if you notice, they're all different. So we're using a normal structure rather than an array of structures.
Yeah, good point, Ben. Class act. That is such a good point. This is one of those, it's a situational thing.
Yeah.
I did it this way because my scale is different for a pizza slice than it is for a T-Rex. And it's different for I think it's this, look at that, look at this one. Yeah, D20. So that D20 is just a little 20-sided dice. Anyone who plays D&D is going to know exactly what we're talking about there. And that has a scale of 120 because a dice is very, very small and the T-Rex is humongous. So when I first made it, you couldn't even see this D20. I made it 120 times bigger to even see it. So it had to be laid out like this. Otherwise I'd just be wasting lines of code. Let's go to a more sort of standard looking structure. We've got tons of variables here. Here we go. Now this one is quite an interesting one. We've got a laser, we've got particles for the explosions that happen when a laser hits something, we've got an array for the explosions of particles to handle all of those different things, the trees, the rocks, the enemies, and I think that's it. We probably have one for the player as well actually. I think that's somewhere else. But these all have different properties. I want state, object position, and colour for the laser. Object position, direction, velocity, colour, and state for the particles. The parts, the alpha, which is the transparency, and the state for the explosions. Object position, scale, state for trees. Now, you might notice that I've got two arrays of structures here with the exact same properties. Not the same actual content in the properties, but the same properties themselves. I've got trees and I've got lasers, and they both have state, object, position, colour. In fact, the rocks the rocks array also is very, very similar. We've got object, position, scale, target scale, but we've also got a couple of extra ones too. Now, this is going to be something which you have to call upon in various times, depending on what's best for you. But what I'm getting at here is a slightly more advanced way to define a structure. And it's something called a type. Now this is going to need a separate project. Well, we'll go back to our little demonstration project in structures. And I do believe this is used in a couple of the FUZE Demo programs. Not a lot of them though, because in truth, if you don't need to use this, there's not really much point in using it. But it will allow you to read everyone's programs more easily if you understand what's going on. And it looks really pro when you do this.
It does.
It really does. Ben, can I borrow the keyboard for this one? I think I am not that you're not comfortable with it, but I've got a good idea of what I want to type here. So there's a keyword in Fuze called struct, just like loop, repeat, if, array, and all that stuff. And we use it when we are defining a structure type. Now, type might not be a word that you've heard before, but hopefully at the end of this you'll understand. We're defining the type of a structure, which allows us to predefine all of the properties. Now, let's say that you are making a game where you want to have 4 different kinds of enemies, and you might want like up to 120 of each one. And you want all of the enemies to have the same properties like health, position, size, colour, anything like that. But these 4 separate arrays, you want to treat them separately. Maybe they all want to be in different rooms or something like that. And you don't want to have to write the same structure 4 times. If that's what's going to happen with you, or if that's what that's a weird way of saying it. If that was what you were planning, this is going to be exactly what you want. So let's make a type. I'll call it enemies type, just to be super, super clear. We end the structure with end struct, just like end structy, just like end if and the like. Is that? Yeah, that should be visible for everybody. So this is the start of it. What we now do is, instead of doing dot pos equals, we define the type of variable that we want to use. Now, because Fuze is very, very friendly, it doesn't actually matter what you do here. You could say, I want this to be a floating point number, or I want this to be a vector, or I want this to be a... what's the last word I'm looking for? An int, an integer, a whole number. And later on, you can overwrite it and you use it however you want. So it's actually really, really forgiving. But you'll see something like this. Let's say I wanted health. That's going to be a decimal point number, which is a float. And I'll call it health. Let's say I want an X position. That will be... let's say I want that to be an integer, just for the sake of argument. X pos. Int y pos. I might want an integer number to store the image that I'm going to use for it. Image. What else could we use as a type?
Size.
Yeah, that can be a float. Float size, and maybe a vector, just to be really pedantic, for the colour. Because all colours are actually vectors. But we will get into that in the upcoming videos, because we don't want to cram too much into these videos. Right, now I've done that, I have just made this new type of variable called enemies type, and I can create an array using enemies type instead of the word array. So rather than doing array enemies 10, if I change this word array for enemies type, I've just made an array called enemies. It's got 10 elements, and each one has these properties. And the cool thing there is I could separate this. I could go, well, I don't know, we could do first enemies or something. First enemies, and then we could do enemies type second enemies. And I might want 20 of those. I could do enemies type third enemies. And I might want 120 of these. I've just made 3 arrays, all with different numbers of elements, all with the same properties, and I only had to define the properties once. This is what we're doing when you see this sort of struct this and struct. And in the more complex programs, especially in some of the programs being made by the very competent coders on the Fuze arena, this is used all the time. It's actually quite a, how should I say, it's a conventional way of creating structures in other languages. I mean, it might not be the exact same syntax, but it's very, very much the same concept. Creating a type, using that type to define something later. In fact, to really blow your mind, you can even say, I want one of the properties to be an array, maybe called inventory, and each enemy could have an inventory of 10 slots. In fact, I could even use my type, I could use a previously defined type as a property. You can keep layering and keep layering and keep making it, making things more and more complicated. And as I'll say again, there's no point in just doing this just for the sake of it. Although I say that, it is good to get the hang of things that way.
Yeah.
I mean, that's how I got the hang of these sorts of things, was just using it when I didn't really need to, but it made me comfortable using it.
Yeah, when you're focusing on using something that tends to be in the background a bit more in other projects, when you actually focus on it and use it a lot, then it helps to drill it in.
It really does, Actually, yeah, so I'm going to take back what I said. There is a good point to doing this. Obviously, if you're just introduced to structures, maybe stay clear of it for now, because you're just introducing unnecessary complexity. But if you've got the hang of a structure like this one, the shape structure, or like in the previous video where we had lots of separately defined elements, why not, step it up a notch and start doing this sort of thing? Also, if you've done this sort of thing and you're relatively new and you really want to impress someone that you're showing your program to, it does look quite pro, I have to say. Not that that should really be a factor in how you code, but it is.
It's a bit of motivation.
Yes, motivation, inspiration and motivation. Thank you, Ben. So I think that about covers it here for defining a structure. Now, I know this video hasn't really been exactly too, what should we say, flashy on the screen. It's been very much text focused, but that's the way it kind of has to be for something like this that is very abstract. And really, in the previous video, we demonstrated how to access these things, got some shapes on the screen. I recommend that you check out the Fuze tutorial on structures, and I think there is also a more advanced structures tutorial as well, which goes into this sort of thing if you want to have another look and to really drill that into your brain. It's quite a visceral way of putting it there, but you know what I'm talking about. What we will do is edit a few of the structures in one of the FUZE demo programs, because I really want to show you, especially you, Ben, what this looked like. And it was an awesome workshop. It actually took place on Monday and Tuesday. If anyone's watching who was at the workshop, thank you for a fantastic day. It was a lot of fun. We'll go into our Crazy Shooter program and let's edit one of these properties. Now, first of all, I need to go to my function that accesses all of the enemy data. I don't know why I'm holding it up here like this. I'll do this.
It makes it go quicker.
It does make it go quicker, because then the gravity when you're pressing down
Yeah.
increases. Yeah, you know what I'm talking about then. So here in my create enemy function, let's just confirm it doesn't.
What does it?
Oh no. You can see this is sort of the typical looking, and this is all over the place in the FUZE demo programs. This is accessing all of the elements of my enemy's structure. So when I say for I equals 0 to let enemies, check over each enemy. If the property of that enemy called state is inactive, so if there's not currently an enemy in there, make a new one. And first of all, I define an index, which is used to choose a random one of the models. So it makes a random number, and that's why it says len enemy models. This just means choose a random number out of however long that model's array is. Now I could just put a number in there, but I did it this way so I can keep adding to it and just add a bunch more models, and so that you guys can add more models too. In fact, I will also show you how to add one, because it's using a structure. But instead of just doing random, let's do the first one. So this is just always, this is going to always access the 0 element of my array of structures. I think that's all about all I need here. As you can see, we're also setting everything else up. We change the ID of the enemy to the index. We set the scale to 0, because you might notice all the enemies go and then reach their scale. We've got the starting position, the object that contains the actual 3D object in the world, the rotation amount, the rotation speed, where it begins, and all these other properties. Take a good look at it. I will go back to my load assets, and here we go. So when I run this, I will just get T-Rexes. In fact, let's just have a look at that. I'm only going to get T-Rexes here. If I shoot my laser, as you can see, we've got T-Rexes coming in the distance. There they are. How fantastic. But they're not very big. Actually, they're just not big enough. Let's make them a fair bit bigger. So I'm adjusting the scale property of the first array element of I messed it up. I did so well before. I'm changing the scale property of the structure contained within the first element of the enemy model's array. There we go. Luke would be proud. If we make it 30. It's so daft. Let's see what happens. As you can see, we've got a rather big T-Rex. And they have to reach their target scale before they start spinning. And this is what... And they still fly towards you, amazingly enough. And they're really quick to clean up as well, because they're so big, you can hit them really easily. And of course...
the bigger they are, the harder they fall.
That's it. Giant T-Rexes definitely have a fair bit of weight to them. If
Except for the fact that they have the same health, no matter what size.
Yeah, just one. Hit them once, that's it. They're really big, but they're very, very fragile, these dinosaurs. So, of course, when I did 30, all the kids in the workshop just went, 100, 100, you have to put 100. So I did. And, I mean, to be honest, when you've seen 30, you've kind of seen it all. It's what it looks like. They get a lot bigger. A lot bigger. I think at the upper levels, it starts to sort of slow down in terms of how big it actually looks. Because, but there we go. So, now you know how to edit and change the properties of some of the games in Fuze. I hope that you have a lot of fun doing this. Actually, before we end the video, I will show you how to add more models to this game and make something as messy looking as this. Let's just get rid of these T-Rexes. Good fun. Oh, I got an error eventually. I think I had a bit of a problem with my scale. Okay, so let's go up to my load assets, and I'll just change this back just for the sake of... We'll make it a bit bigger. I think that was a bit too small. And we'll go back to my create enemies function. Where are we? And let's make this random again, because we want to see all of the models, first of all. Remember that part, it's very, very important if you want to just have one model, and if you want to test what it looks like. You know? But you have to keep a note of which number that is in the array. So let's go back up to load assets. Oops, don't want to do that. And let's add something to this structure. Now, a really easy way to do it is to copy one of the elements. And if you want a really easy time, copy the second to last one, because then you don't have to take away the comma. So we're adding a line here, pasting it in. I don't have to change the comma or anything. I'll just separate that one because this is the one that we're talking about. And all we need to do is go into the load model, press F2, go into the media, and we'll choose some random 3D object. Let's go with... I like Devil's Garage's objects actually, because they're good for random things. He has a lot of food assets as well, which I really like. Chess pieces, a lot of dice. So I mean, this was actually where I got my dice from. So shout out to the Fuze artists. It's absolutely brilliant what they've done here. And eventually we'll get to right. Ben, I want you to choose for me something to put in the game. Look at that carrot looking so cute. Snack cheese is already in there if you see snack cheese, so we can't choose that. Any jumping out at you, taking your fancy? What do we
I
think?
kind of want to just see them all.
I know.
And then choose after.
Yeah, fair enough. I like the milk actually. Pancakes are always good. Pumpkin radish sandwich. Oh, I'm going to lean heavily on that one. What do we think?
Toast.
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 Nice bit of butter on that toast
Yep.
as well. Visible butter,
Yes.
no less. That's how I like my toast. Right, so we
Hasn't
select
even
it.
been- It's pre-spread.
Yeah, it comes pretty spread. There's actually also a knife that you could. Good idea for a game. You know, toast could fly in. You've got to use motion controls to spread that butter on the knife. Right, there you go.
Someone make it.
Someone
make it,
please make that.
Someone
also-
do it or I will.
Yeah, there you go. You have to beat Ben to the punch. And let's make a toast.
And then a
simulate it.
tea drinking game.
Yes, with biscuits, with donk. We turn our variables game, guys. I mean, how can you hear that idea and not just do it instantly? So if we paste that into the load model, you'll see that we don't even have to delete the old model. It's just there. We have our toast. Now we're going to want a bigger scale than 0.1. That was the scale that we had for the planet, which is the size of a planet. Let's make it nice and big. 80. 180. And this is the second to last element. So let's actually just adjust that function again so that we have only got the toast. I think that's going to be len enemy models -2, isn't it? I believe. Because len enemy models -1 will be the last element.
Yeah.
Yeah, cool. Create enemy, and where are we? Index equals len enemy models -2 at the end. So we're not choosing. So len enemy models is the
I hope it
whole
is.
length. Eh?
I hope it is -2 now.
Let's hope. Let's see what we get. Hopefully we get big old toast that we can shoot down. Maybe if we introduce some knives into this. I'm not seeing any toast right now, Ben. Is it
There
too
it is.
small? There it is. There's a piece of toast somewhere. Oh, they're coming in. They look like UFOs. I'm actually a little bit scared. I think, you know what, it's because it's taking so long to get to the scale it has to get to. Maybe 180 was a bit too big, but eventually these are going to start rotating at some point. Because I didn't want them to just sort of go bang and appear too quickly. I made the scale increase gradually. But here we go.
There we go.
Right, let's dodge. That's a big piece of toast. It's going to it'll take a while to get through that toast. Right. That was a good laugh. I enjoyed that.
Agreed.
Right, okay, I'm going to let that just sort of play. Guys, I hope you've had a good time watching this video on structures, and hopefully now you feel better equipped to go into the Fuze projects, change them. Here you go, man, you have that second controller so you can play while I'm talking there. Thank you so much for watching. All the positive feedback that we've got is genuinely so moving and motivating to us. We just we just want to bring you more and more videos. We've got lots of plans for videos coming up. And I want to mention actually in this one, I know, just pay no attention to that. I want to mention in this one that we're actually really close to 1,000 subscribers, which is really exciting. I think we're on like 968 at the time of recording. So we only need 22 more, 32 more. I can maths.
I English good.
When we get to 1,000 subscribers, we want to do a special video, which is something of a showcase of some of our projects that we like and some of the Fuze Arena awesome showcase projects. So I'll be contacting you. I think I might have already contacted some people, but I'll be contacting you if you've got an awesome demo and we can show some things off. So let's get that subscriber count to 1,000 so that we can make this awesome video and just show off what we can do. And yes, I am mean, and I want to wait to 1,000 subscribers because we're so close. You know, it's not 10,000. We can get there. I think that about covers it. Ben, is there anything I'm missing?
Don't believe so.
You don't believe so?
I think you've got it.
Got all the housekeeping out the way?
Yep.
Cool. Right, guys, thank you again. check out Fuze Arena. Don't forget to like, share, comment, subscribe. I'm going to get bored of saying that eventually, but you have to say it. It's the rules. You know, we've all seen enough YouTube videos to know. So, thanks again. I've been
In fact, you
Dave.
should record it and then just
Yeah,
play it.
maybe if we have a little TV that I could just sort of bring up from the bottom like this. There you go, and press play, and then we can stare silently at the camera while it says that again and again.
For about 3 seconds, and then we can take the enormous screen away.
Yes, we'll have to lug it away. We'll probably want a really big TV. Well, we're going to be here for another half an hour if we go down this rabbit hole. So, guys, I've been Dave.
I've been Ben.
Thank you so much. See you next time.